Hey stats class, we're going to look at this problem from the 7-1 homework set, and I'm going to in this video show you how to use the TI calculator to do this problem. So we want to find a 99% confidence interval for the percentage of the population that feels vulnerable to identity theft. So it starts off asking us to find the point estimate, and you can get that straight from the screen that you have here. So you just take x and you divide by n, and that's how we always find the point estimate. But the rest of the calculations are a little tougher to do with the TI calculator just on the faceplate right here. So what I encourage you to do is to find the rest of these with the built-in confidence interval feature of the calculator. So that's going to be under the test menu, so you need to go to stat and then come right over here to tests. And this is a confidence interval about the percentages of the population that feel vulnerable. So that is a 1 prop z interval. So if we come down, that's 1 prop z test. That's chapter 8. So there's what we want, 1 prop z int. Right, it's A on mine. It might not be on yours. Just different versions of the TI have more and less features. So just look for that 1 prop z int to make sure it's a 1 and not a 2. All right, you want to know x and n again that we just did, 580 and 1057. It's labeling them x and n. It won't always do that. Just know x is going to be smaller than n. N is the whole sample size, and x is the part of the sample that have that quality that we're looking for. All right, 99% is 0.99, and then we calculate it. Now, there is the two numbers that I get, and the margin of error is half this distance, or you can think of it as the distance from the upper number to p hat, the number in the middle, or it can be p hat to the lower number, whichever one. But notice there's p hat also, the 0.549 that we got on the home screen. We could also get that straight from doing the 1 prop z interval. All right, so what I want to do is subtract this upper number. I always do the upper number. The upper number, 0.58815 minus, make sure you use minus and not negative, like I was just doing, 549. All right, so that is my margin of error. And again, I only need to round it to 3 places, so 0.039. And then it wants the confidence interval. So that again is what I get when I run the test, or sorry, do the interval. So rounding these to 2 places, there's the lower number, 0.509, and the upper number is the 0.588. All right, but all these two numbers are is the p hat that we got on part A minus the margin of error we got on part B, p hat we got on part A plus the margin of error we got on part B, and we would get those two numbers. Now, when we interpret it, this is the big thing. Your calculator can find the intervals for you. You still need to know what you've done here. So we have 99% confidence. All right, it's got to say confidence. So there's one that says 99% confidence. There is another one that says confidence. The other two are eliminated. It's a confidence interval, and they're not talking about confidence. So it's going to be either A or D. A says 99% confidence. The interval contains the true value of the population proportion. That's what a confidence interval is. It's going to be A. We have confidence the sample proportion is equal. No. We have 0% confidence. The sample proportion is actually equal to the population proportion. So a confidence interval is an interval that's wide enough that we feel confident that we have the value we're trying to estimate in there. And that thing we're trying to estimate is the population proportion when we're doing a confidence interval about a proportion. So that is the interpretation, and that should always be there in your interpretation, is that word confidence. And you're always confident the interval contains the value you're trying to find. That population parameter, the mean, standard deviation, or the proportion, like it is in this problem.